John's. It's Group Beta Harambe team.
Austin.
Ben.
Lesson 12.
Lesson 12. We're in the MC today. Internet's been spotty, so sorry if you can't hear us. I guess
Kind of.
it's not that our banter is very constructive, anyway. So okay. So
We are geneticists. Everything
we started going over the problems before I even started the video. So we're on,
That's the truth.
I think 3.
It is true.
We're on 3. 3B. Beta. Okay.
So the operator site is the sequence that provides a binding site for the repressor protein. So we're trying to find out how the gene expression would be affected if that operator site, aka the
Was defective.
sequence that has the binding site area, was defective.
Well,
So what would happen if that operator site was defective? We would be able to have an inducible, non-inducible or constituted.
wouldn't it be non-inducible? Since
That's what I put for A.
yeah,
Because I feel like if any of these weren't working, then they wouldn't work.
Yeah.
Well. I mean, the genes, on the other hand, it's a
Hmm.
little different because it's a structural. It just codes for the B galact, like for at least the LAC-Y gene.
yeah.
It codes for the B galactosidase, while
Galactosidase.
lactosidase.
Thus, LAC-L- produces constitutive expression of the LAC operon and is considered to be a constitutive mutation
So it for
for the LAC operon.
the LAC operon. So this is the thing. The LAC operon has all of those things in it. So it has the LAC promoter, it has the operator site, it has the genes. It's that prog I was telling you about, remember?
Mm-hmm.
It's from a video. Super sick. Bozeman science, man.
Bozeman.
Hey,
Neil
so-
here.
This is Mr. Anderson again.
This is Dr. Anderson.
Dr.
We're going to talk
McMacklin.
about Mendelian inheritance today.
What are you guys
Mr. McMacklin.
Mr. Maggie. Okay.
We're gonna look about genetics today.
That's.
Someone decided to come over in a urinal, took Patsuki.
Oh my gosh. Sorry. The operator site. So this is the LAC-O gene, right?
Yep.
So this sequence provides a binding site for a repressor protein. So if the repressor protein is unable to bind,
Ooh, this is good.
so
The LAC operon in absence.
I think it would be inducible.
So inducible means that it's always going to be active.
Yeah.
Non-inducible means never active.
Because it's going to be bound by something else.
And constitutive. I guess I don't understand.
Constitutive?
I don't understand the difference between constitutive and
I don't understand constitutive.
inducible.
The definitions on this are very
Provides a binding site for a
I
repressor.
don't understand the definitions.
I think from the operator site definition, it's
Doesn't
the
have
binding
no-
site for a repressor protein. So if it's mutated, then the repressor protein can't bind to it, which means that transcription won't be turned off.
Yeah.
Does that sound correct? I'm gonna go with it. I keep thinking people are talking to me. I used to be cool, I swear.
You're going crazy?
I am a little crazy. It's true.
There's
Keep
all
talking to me, Ben.
I got
voices in my
I
head.
got really weird after I got married. I mean, it was pretty weird at the beginning.
Someone's telling me to go dance on the stage right now. Ben, who's telling you?
Nobody is telling
Ben,
me
where'd you
that.
get that gun?
Colin, put your clothes back on.
Sorry,
He's-
Mr. John.
Sorry. Okay, so operator site if I'm putting inducible.
So this one is not even saying we have to have an explanation.
Well, it says how would it be affected. Well, I guess it does offer then inducible, non-inducible, or constitutive.
I know that on number 5 you have to.
Really?
Inducible.
Repressor protein would be unable to bind to the operator site, which prevents transcription termination. So the lac Y gene is... I hate genetics so much. I love it. A structural gene that encodes the enzyme lactose permease, which is a membrane protein involved in the transport of lactose into the cytoplasm of the cell. So lactose is prevented
So that means that there's no transport of lactose into the cell.
Yeah.
And if it can't get into the cell, it's not going into the nucleus.
So if
Yeah.
the operator site is not there, then that means it can't bind, right?
Repressor proteins couldn't bind to the operating sequence.
So
Which would
it
be
is inducible.
Yes,
Lack
in my opinion.
promoter means that it starts it. So then, if that's defective, then it's non-inducible.
Yeah.
Yeah,
Because
that
a
makes sense.
sigma factor can't bind to it or something?
Yeah. And then the lac Y gene is what produces.
It transports lactose into the cytoplasm.
You know that.
I just read it.
Structural gene.
Yeah.
Lactose permease.
Without lactose in the cytoplasm,
Well,
So is that
Inducible?
constitutive?
constitutive. Let me reread the definition for constitutive. Okay. So some genes are always transcribed. These genes are always on and are called constitutive or housekeeping genes. Oh, okay. But the constitutive
so
genes
this one
produce
can't be because it's not always on.
products of these genes are required for the normal function. I'm so confused. So it contains all of the genetic sequences required for the cell to survive. Wasn't that the definition of a housekeeper protein or something?
Yeah.
Or housekeeper gene?
So if that's defective, the lac Y gene will not. That doesn't make sense. I don't know how to apply these definitions to these questions.
I think like if the lac Y gene is defective, then it's not able to make the enzyme lactose permease,
Right.
which prevents transport of lactose. So what does lactose
But how
do
does
in the
that
cytoplasm?
affect? How does that affect gene expression?
Well, I think that the
Well,
last
lactose permease isn't made. The enzyme.
Oh, so it's non-inducible.
it's not that I think in the cytoplasm that it matters, it's that it gets
In the
through the
nucleus?
cytoplasm.
Oh.
Because when it gets inside, the lactose will be a binder to certain proteins that then cause, like for example, bind to the repressor, and then from there, that's how the RNA polymerase will be able to bind onto its other and then push its way down the gene line, right?
He's so
Through the operon.
Good.
I believe
Good
so.
comment.
Good description. I like that a lot.
Thank you, thank you.
I believe
So
you.
what about the lac Z gene?
Eh,
The lac Z.
lacking Z's, boys. We're lacking Z's. I'm definitely not lacking Z's. I got a lot of sleep last night.
Me too. It was awesome.
Felt really
I
good.
hate you guys.
Was the
I didn't
baby
fall
up
asleep
crying?
till really late, but
What I do is I open my window and then boom, nice and cool. I get to snuggle up in my covers. And,
if I didn't pay for utilities, I would do that in a
Yeah.
heartbeat.
I mean, what do you mean?
Well,
Your bedroom window?
Yeah, but then it goes into
all the heat.
Yeah, it
sucked
goes
out.
everywhere else. And if you turn your heat off,
Well, you shut your door and you like barricade it.
then you have to turn your heat off in your entire apartment, and then your entire apartment would be freezing cold, and you get up to go take a shower.
And I wouldn't get up.
Yeah.
Okay, fine. Sorry, I don't
Enjoy-
freaking live the
no.
struggle.
Enjoy
My
this.
apartment's always at a 60, it's like a steady 69 degrees.
Nice.
Ours is at
That's
like
what
a
I said
steady
it at, too.
73.
Yeah, I
Ooh.
can't
My
stand
wife
it.
loves to be
Ew.
hot. I know,
Gross.
I
Can't
hate
stand it.
I hate it.
Kendall likes to be colder than I am.
Oh, I love to be cold.
I
Me
don't.
too.
Man. My feet get wild. can't.
My feet are kind of cold right now.
freezing.
Dude, wool socks. Ooh,
Yeah.
change your life.
I can be like sweating everywhere else in bed,
I remember.
but my toes are freezing.
I remember I would like, last year. The first couple times I went snowboarding at Targhee, I wore cotton socks.
Oh.
Never again.
Feet were ice cubes, dude.
Yeah.
Like
I wear a lot of cotton socks.
couldn't
too.
freaking move my
Wool
feet.
socks
Dude,
are expensive.
Do you guys remember
I only have like one pair.
last season when it got to like minus 10
Yep.
up in Targhee? My buddy went, and he had a friend that he went with, and like he got like frostbite on 3 of his toes.
Ooh.
Dude.
Did you have to have them amputated?
No, luckily they got him down fast enough, and he was able to
I'll
like
tell you what.
Nice.
warm him back up.
Leave him.
You get some nice. Get the Cabela's wool socks, dude. Holy smokes! You put those suckers on your feet. You pull your
Smart
boots off,
wool?
and your feet are steamy. Steamy.
I think
You know
I-
what underwear I
blood
want just
circulation.
because of a commercial?
Huh.
Duluth underwear.
Oh yeah.
You know what
I wanna
I'm
get a
talking
Tuggy.
about?
You guys seen those?
No.
Tough enough to
Tuggies?
throw a
Remember the
pigskin.
Snuggie?
Yeah.
Tuggy is the same principle, just around the wing.
That's on your what?
Hope you weren't listening to this part of it.
on your wing.
Yeah. So Lax Z.
I think this one's gonna be constitutive.
Have you seen those though? The Duluth underwear? Those commercials
Duluth underwear?
Yeah.
Strong enough to throw a pigskin.
No, I haven't.
Commercials
Me too,
are
apparently.
so funny.
They are pretty
Huh.
It's just kind of
good.
what regular underwear feels like. And it's like he gets in a vice and he like twists a vice onto his junk.
No, oh my
And then he's like, and what it feels like wearing Duluth underwear. It's like a lumberjack guy like
No.
skipping around. And
This,
like,
oh, I think I might have seen one or two of
Those are
those.
funny.
That's funny. Oh, okay. So without Lax Z, beta-galactosidase isn't produced,
right.
which converts lactose to allolactose.
Ooh, allolactose is really important actually.
So allolactose binds to the repressor. Ah, so it's inducible.
Or is it
No.
constitutive?
Constitutive? Constitutive?
I still have no idea.
Well, constitutive are the housekeeping genes, right?
Should there be one that's constitutive?
That's what I was thinking.
I don't think so. I'm not doing it. I'm doing inducible.
I'm saying
Damn the
constitutive.
torpedoes. Full steam ahead. Inducible is what I'm going with. Excuse me. No
Alright, so 4.
galactosidase is produced which
This one was another weird one that I was
convert
confused on.
lactose.
The experiments that they ran were pretty interesting, but very vaguely described in the notes.
So beta O.
I'm pretty sure A is right. It's just, why was no color observed? So the thing was, yellow, when you have this compound, the nitrophenyl galactoside, when it is introduced with, I forget what broke it down, but it separates into its 2 constituent compounds,
Beta-galactosidase.
which are galactose and then nitrophenol.
Yeah.
The nitrophenol becomes, it shows off like a yellow tint to
The
it.
nitrophenol is colorless.
Are you sure? I
And
thought the nitrophenol was
oh no,
yellow.
the nitrophenol is yellow.
Yeah, so the nitrophenol is yellow and the galactose is colorless. So
Yeah.
the next question kind of had me stumped, and it's saying why was no yellow color observed? Is it just because there was an absence of nitrophenol in the end product?
That makes sense.
Yeah, that's the only reason it could be, right?
Yeah. What did you guys use for A? For say for A?
That when broken down, it goes to galactose, which is colorless, and 0 nitrophenol is yellow.
It forms. Oh.
Okay, and then so what is another method that can be used to measure the level of expression of the lac operon? which I had no idea about this one.
Oh, what is another method that can be used to measure the level of expression of the lac operon? You could see how much product is produced.
How much?
How much production of product was produced?
Yeah, how much product is produced. Right? That could be another
Yeah.
way.
Sure. That's fair.
If you find out how much product is produced, then you know how much gene expression is going on.
Oh, so levels of CAMP.
Camp? The cyclic AMP?
Yeah. So if glucose levels are low, adenyl cyclase activity increases, producing high levels of CAMP.
So you could measure CAMP
Yeah.
levels.
Measurement.
To the level of CAMP.
Measurement of cyclic AMP would do what?
It would give you the level of activity of the adenyl cyclase.
Adenyl cyclase?
Adenyl
Adenylyl
Adenyl
cyclase.
adenylyl cyclase.
Adenylyl cyclase. So the big thing with that is that if there's a low level of cyclic AMP, doesn't that make it to where
High level of
there's no
adenylyl
signal side? Like there's no positive signal, so that makes it to where there's no binding for the proteins later on.
Right, but this is we're assuming that it's like intermediate levels.
Yeah.
Hopefully.
Okay.
Are you
Sister
just-
John's, we're assuming that it's intermediate levels.
Intermediate.
Yeah. Intermediate.
Armenian levels.
Okay. So why was the optical density twice as high in tube 4 as in tubes 1 or 2?
Oh, we didn't.
If I get another cold, we'll lose it.
Yeah, dude. I feel like
What time are you guys going to the
still
gym?
haven't gotten
I'm
better
still
yet.
like getting off.
Like
What?
8 or 9.
Oh, 8 or 9.
Yeah.
What time are you?
I don't know, that's for you guys. I'm trying to figure that out.
Why? When do you want to go?
I was thinking sooner rather than later.
Really? My wife just doesn't get off till 5, so.
Eat dinner, 5:30.
Oh,
Put you at 6.
Okay.
it will put me at 6:30. I can't go to the gym until after I've had at least an hour to digest.
Did we do D?
No, not yet.
Duty.
I'm trying
Duty?
to figure it out.
Nice. Focus. I have to go to the bathroom here in a second. Okay.
I just went to
So
bathroom
the
one
lac
day.
operon is expressed in the control tube minus lactose tube 1 and the experimental tube plus lactose tube 2.
Do you see that in the notes?
Yeah. The mutant strain Lacey. Is that how you say it? Lacey? Lacel?
Wait, did we do D? Optical?
No. Why was the optical density twice as high? So allolactose.
What about it?
Allolactose. That seems like a. Isn't that a?
That's an intermediate thing that binds to the promoter.
Yeah. Is it like a enantiomer or a racemic mixture? Some different form of lactose?
What's your question?
So the optical density. So if there's less allolactose, that would mean that there would be more straight lactose.
No, so listen to this. So when lactose is present, lactose is converted to allolactose,
Uh-huh.
and that binds through pressor and releases it from the operator.
I'm
The lac
good.
operons on the chromosome and on the F
Watch the
plasmid are
videos.
now expressed.
Okay.
And so I'm guessing that the reason is because
No lactose was being converted
Guys,
to
intro to
allolactose?
dog sledding?
What? Winston, we should put him in that.
we need a fish.
Dude, he would not do well. He would not do well. He's a California dog.
Do you not like the snow anymore?
Is it he has really cold feet.
Give him a little dog mittens, dude.
We are. That's what we're getting him for Christmas. We got him a denim jacket already. Super cute.
Your poor dog.
He loves it. He's the most needy dog ever. Like, some serious emotional instabilities.
So I think that the reason is because there's no lactose and no allolactose present in the tube.
Tube 1 had no lactose, while tube 2 had no, like, lac operon, I think.
Yeah, tube 1 has no lactose. Tube
Oh,
2 has lactose.
But no,
No
Lac-
no allolactose. And tube 3. Oh, sorry. Lactose is absent in tube 3 as well. And then tube 4, lactose is present, but it's converted to allolactose, but then it releases
I'm just gonna leave it what I have.
plasmids.
That's
So,
crazy. Alright.
so wait, what'd you put?
I just said because in tube 1 there's no lactose, and tube 2 had lactose but no allolactose.
Okay.
Okay. I'm not sure how else to.
Okay, and then for 5, I'll run through these quick. So describe how the lac operon is regulated under the environmental conditions listed in lines A through D. For the question, it is not sufficient enough. Okay, so we have to describe why it will be either transcribed or not transcribed. So it'll also want us to indicate why the lac operon will be transcribed or not transcribed. So for A, there is no glucose or lactose present. So we know that it can't be transcribed because without lactose, the lac operon or the lac repressor remains bound to the operator, which hinders transcription. When glucose is present and there's no lactose, basically out of all these, there's only one way you can transcribe.
It has to have lactose.
It has to have lactose, and there cannot be glucose. So, if anything is in contrary to that, then you can't have an operational operon, aka operon.
Lactose, the lac repressor. Okay, yeah. Leading to.
So B is not transcribed because there's low cyclic AMP levels, and the cap doesn't work. It won't bind because the cyclic AMP can't have a positive signal for the cap to bind to. Without the lactose, the lac repressor remains bound to the operator, which hinders transcription.
So low AMP levels, that's a negative signal, right?
So the cyclic AMP is supposed to produce a positive signal that makes it to where the cap can bind onto the DNA strand.
Okay.
And if there's a low level, then you're gonna
There's not a strong enough positive signal. Okay.
It's gonna be too weak. So with C, with the lactose present and no glucose, we can have transcription because it has high levels of cyclic AMP, which allows for, this is the big thing, the cyclic AMP gives a conformational shift on the cap, which allows it to bind. So it's, like allosteric hindrance, remember that?
Non-competitive and
yeah, you remember the difference between those?
Inhibition.
So whenever we have a protein that binds, or some type of molecule that binds on the protein, it changes the conformation of it and allows it to bind on.
That's allosteric inhibition?
I think so.
I think you're right.
Wait, what?
Competitive inhibition is where it binds directly to the active site.
There's 3 different binding to it. So if allosteric is just one.
Competitive inhibition is they're working for the same binding site.
Exactly.
Allosteric is opposite binding sites, but if you have one bind to one
It'll
binding
do
site,
it,
it
and
closes.
the other will do the opposite.
It closes the other binding site.
Yeah.
So that would be the condition with lactose and not.
Gotcha.
Or cyclic AMP and not.
Mm-hmm.
So we have that, and it allows the cap to bind, which then allows the repressor to, let's see.
Please don't die, please don't die, just let me submit this.
It allows the repressor to release its bind to the operator, which is pretty cool because then it allows the RNA polymerase to push to the chain. Yeah. Because if we have the repressor there bound, then RNA polymerase can't move. And then with D, glucose, We can't have transcription because it also has low cyclic AMP levels, and that means that the cat can't undergo any type of conformational shift. And without that positive signal in the shift, then we can't have a movement of the, repressor. And with no movement in repressor, we have no movement through the gene cycle. Oh yeah.
You guys talking about me?
No.
Nope.
Sure.
Yeah. Positive. We want to talk about you right in front of you.
Yeah.
Thanks, guys.
Yeah, we'd make fun of you.
We
behind
at
your
least
back.
go somewhere else. You're a friend. We don't make fun of friends.
Thanks. I'm just paranoid.
I don't know if I don't make fun of
Hungle fever.
It's real. Dude, that was real because, like, in Chicago, people